Hi, welcome to another e-learning video. In this video, I want to discuss about quiz 2, which you have taken recently. Now, the question 1 reads as follows. The supply voltage is Vt equals 325 sine 314 volt is applied to an electrical appliance with the equivalent circuit as shown in figure 1 below. The supply current is determined to be IT 10 sine 314t 45 degrees phase angle. So we are asked to find, first of all, the frequency of the supply voltage. We want to find the RMS value, and we want to find the V and I in a complex form, or complex number form. And then finally, we want to calculate the impedance Z of the circuit. And then we determine the R and X value in this circuit. Finally, we want to know whether the circuit is resistive, inductive, or capacitive. And we have to explain the answer and determine the power factor of the circuit. So there's quite a lot of things for us to do. And well, let's quickly start into this. First, let's get into a bigger picture. Now, the first thing we want to do is to know that from the V formula, we are able to derive a few information. We know that from the formula, the omega is equals to 314 radian per second. And this is also equals to 2 pi f, which means that the frequency can be calculated from 314 divided by 2 pi. And that gives me about 4997 or something like that, which is, you can say, round up to 50 hertz. Okay, so that's the first answer. Next, we want to find the RMS value. Now, if you recall the RMS formula, V RMS is equals to V peak divided by root 2. In this case, V peak is 325 volt divided by root 2. That will give us a value of 229.8 volt. And move up further, IRMS will be I peak divided by root 2 equals to 10 over root 2, which gives me about 7.07 ampere. So these are the two RMS values that I need to calculate. And finally, we have the part 3. We want to express this in complex format. So complex format is VRMS 229.8 volt, angle 0 degrees. I should be doing this way. The V should be here, right? It's the reverse. Good. And the I complex number is 7.07, angle 45 degrees ampere. These are the two complex numbers. Now next we want to calculate the part 4. Part 4 we want to calculate the impedance. Now impedance according to Ohm's law is V divided by I. So if we were to write this down, V is 229.8 angle 0 volt divide by 7.07 angle 45 degrees. That gives us impedance value of 32.5035 at an angle of minus 45 degrees ohms. Okay, and to find the R and X component, all I need to do is convert Z into the rectangular format. Remember, rectangular format is R plus JX. So from here I can calculate R is Z, the magnitude that I've calculated, cosine the angle. So that's 32.5035 cosine of 45 degrees. That will give me a R value of 22.983 ohms. Okay, so that is the first component. I move up a bit, and I can continue to calculate the X. Now X is given as Z, the magnitude, sine theta, the angle. So that's 32.5035 sine of 45 degrees. That will give me an X value of 22.983. 22.983 ohms. Right, notice that actually we have a negative 45 there. Negative 45 here. Right, so I should be writing a negative sign there too. I should be writing a negative sign here. Negative 45 degree, and here should be negative 45 degree as well. Right, which means that I have a negative X. So if I were to write the full equation, it should be 22.983 minus J, 22.983 as well, ohms. Right, so R is 22.983 ohms, but X is a negative. So what does that tells me about the characteristic of this circuit? So moving forward to all this, now it tells me that the angle is minus 45 degrees. So in other words, if I now look at question part 6, the circuit is inductive because the voltage leads the current by 45 degrees. Therefore, the power factor FP is cosine 45 degrees, which is 0.707. Current is behind, right? So it's lagging. Okay, so that's the answer.